Hey guys, today I wanted to talk about box plots. We had talked yesterday about the 5-number summary. Well, the reason why we come up with those 5 numbers is so that we can draw this graph called a box plot. So this is lesson 12-3. I know we're skipping over to a new chapter, but this ties so directly with what we've been talking about yesterday, it just makes sense. So, box plot. And the date for today will be the 23rd of May. So let's give a definition to a box plot. And a box plot has another name. This is what I originally was taught was a box and whiskers plot. And the reason for that is there's 2 components to this plot. There is a box in the center and then 2 strands coming out from either end, which look like whiskers, I guess. So this uses a number line. To show the spread of data. Remember, it's all about measures variation. By plotting the 5-number summary. Okay. And that includes the median, the quartiles, the Q1 and Q3 quartiles, and the extreme values which are the minimum and maximum. So those are the 5 key ideas. So the box part is all 3 of the medians. It starts at the quartile 1, ends at quartile 3, and with a line drawn through the median. So the box does have a line always indicating where the median is. The whiskers they just connect the box to the median, or sorry, not the median is what I wanted to say. I wanted to say to the minimum, too many M words, huh? And the maximum. So to the left to the minimum, to the right to the maximum. Okay. So what I'm going to do is, let's go to a new screen so we can draw a box plot so you can see what it looks like. I'm just going to create one for you. So it has a number line so that we can understand where the points are. We're going to count from 80 and we'll stop at 220. So 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220. And we're going to plot 5 points. First one will be at 90. Second one will be at 120. Third point is at 160. Fourth point will be at 200. And 210 will be the last one. So I'm going to write above what each one is. We've got the minimum here on the left. On the right we have the maximum. In the middle of the remaining 3 points, this is your median. And then we have quartile 1 between the minimum and the median. And we have quartile 3 between the median and the max. Now, let's draw in the box. So we draw vertical lines through our quartile 1, median, and quartile 3, and we connect them up. And then we connect the whiskers to the box, or the box to the whiskers, however you want to say that. And that's what we got. So minimum, maximum, quartile 1, quartile 3, and median. Now yesterday we talked about how each of these quartiles represents 1/4 of the data. Well, we're going to go a step further, and we're going to talk about being 25% of the data. So we're going to add the idea of percents now. So each of these 4 sections is 25%. Now what's weird is not all of those sections look the same size, even though they represent or contain the same amount of data. So let's just jot down a couple reasons why the bars aren't all the same length and the whiskers all the same length. So why are the quartiles different? So let's write that. Why aren't all quartiles drawn the same length? So remember, this is all based on variation. Variation deals with spread or distribution. So let's, reason 1, the greater the range, of data, the greater the length. Oops, sorry about that. Thinking the next word ahead. The greater the length of the quartile. Okay. And conversely, the smaller the range, of the data, the shorter the length of that quartile. Okay. And excuse me, if the quartiles appear similar in length, then the ranges of those quartiles would be similar. Not identical, but similar, right? Okay. So let's do an example that will take our data, turn it into a box plot, and then we are going to answer some questions regarding what we see in the box plot. Okay, so in our data we've got, we're going to draw a box plot. Of the car speed data. So basically they were taking some information, or maybe there was one of those machines that was out that calculates your speed as you drive by, and looks like it would be in a residential section. My neighborhood, 25 miles per hour is the speed limit, though it's not always followed by everybody. And these are the numbers they came up with: 25, 35, 27, 22, 34, 40, 20, 19, 23, 25, and 30. So what we talked about when we want to do the 5-number summary, the very first thing we have to do is get the numbers in order from least to greatest, and that's going to be the fastest way of being able to get our data. So let's do that. And remember what I showed you yesterday. What I do is I look at my numbers. I have numbers in the 20s, 30s, 40s, teens. So let's start with the teens. So 19 would come first. Cross it off. In the 20s, I have 25, 27, 22, 20, 23, 25. Lots in the 20s. So the smallest was 20. So it looks like 22 came next, followed by 23, followed by 25, 2 of them actually, and then there was a 27. So in the 30s, we have 35, 34, and 30. So 30 would come next, followed by 34, 35, and 40 was the last. Okay, now that we have them, we're going to identify our minimum and our maximum. We're going to identify our median. And we're going to identify our quartile 1. And we'll identify our quartile 3. So minimum and maximum are the easiest ones. Minimum is 19, far left, far right, maximum at 40. Now let's look at our data. How much do we have? Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. Perfect, odd number. So 11 cut in half would be 5.5. So the number after the 5th one is going to be our median. 1, 2, 3, 4, 5. So we have 5 numbers in front, 5 numbers behind. So our median is 25. Quartile 1 is the median of the first half. There's 5 numbers, so 22 is going to be the quartile 1. And in the second half, again, we have 5 numbers, so 34 would be that value. All right, so now what I'm going to do is calculate the range, and the range is going to help me figure out what I'm going to count by on my number line. If I have a small range, I'm going to count by 1s or 2s. If I have a larger range, 5s, 10s, whatever it takes. So let's do that calculation. And remember, the range is just the difference between the maximum and the minimum. So let's see, we're going to get 21. So 21, I'm going to say I'm going to count by 2s. Counting by 1, I have 21 little tick marks. We'll count by 2s. Okay, so we're going to start at 18. So that's, and we usually start with even numbers anyway. And the key with doing this is we want to make sure that we keep our intervals nice and even. So here's 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and we'll go ahead and stop at 40. Now notice that I'm almost getting to the point where my numbers are just looking like one big huge number. So having drawn perhaps a little bit bigger would have been a little bit better, but it is what it is. So let's start graphing. 19 would be halfway between the 18 and the 20. And then we've got 40. So notice that my box plot is not going to be on the line, it's going to be floating above it. Quartile 1 is at 22. And the median is going to be at 25, so halfway between 24 and 26. We've got quartile 3 is at 34. Okay, I'm going to beef up these dots just a little bit. It's a little tricky on the iPad. Okay, so now we're going to go ahead and do our box plot. We're going to draw through the 3 medians, making our box, and then connect to our extremes. All right, now we'll title this car speed. And afterwards, we'll probably get some questions we're going to be asked. So here's the first one. Half of the drivers were driving faster than what speed? So we look at our graph, we find the median. The median's super easy to find. The median is that vertical line inside your box. So that's at 25, so that would be 25 miles per hour. Okay? So half are driving faster than 25, the other half are driving less than 25 miles per hour. Here's another question. What does the box length tell about the data? Okay, so if you notice, the left part of the box, so from quartile 1 to the median, is a lot shorter than from the median to the quartile 3. So basically what that is saying, here, let's color this one up. The left part of the box is shorter than the right half. That means the slower speeds are closely packed and by that I mean we had a repeat of several numbers, or the numbers were very close to each other. The range between those particular numbers was very small. We went from 22 to 25. The faster speeds were more spread out. And if you notice in the box, we go from 25 all the way to 34. That's a huge difference than what was on the left side of the box. All right, let's see if I can smush in one more question. Oh, this will be an easy one. What % of the drivers were driving faster than 34 miles per hour? Well, if you look where 34 is, faster than that would just be that whisker piece going all the way to the maximum value. And remember, each one of those 4 quartiles represents 25% of the data. So that's our answer, 25%. Okay, now on a test I would write 25% of the drivers were driving faster than 34 miles per hour. But you see what I did here. I didn't leave myself a lot of room to work. So again, the key idea to remember, each piece is 25%, with the box representing 50% of the data. Okay? All right. Good luck with your homework.